Thank you, sir.
Thanks, Carl. Well, the jet lag got me this morning. I don't know how many else was affected by it, but I rolled over and I'm like, oh, I need to get up. Yeah. And thanks for that. Thanks for starting off. It was a really good discussion. When we got started at Semper, almost 6 years ago now, our focus was on really just relooking infrastructure as a capability that is vital to what to basically everything you do. I don't think people really are aware of how reliant they are on infrastructure today, digital infrastructure. It's kind of gone past a place where we probably should have been caring about it, but we're just completely oblivious. Sorry. My first attack. Availability, right? So I grew up flying bombers. Spent a lot more time doing it than Carl did, but so one of the things that we had in the B2 was communications that importantly they were redundant, but most importantly they didn't quit no matter what the problem was. We talk about service availability, SLAs in the commercial space. There's no such term in the military. It is either your stuff works or it doesn't. And our stuff is built to be redundant, to have multiple systems, to take a beating and continue to operate. And it was this context that I watched the outcome of Hurricane Katrina unfold. So I was at Whiteman Air Force Base flying B-2s. This is 2005. How many of you remember Hurricane Katrina? Remember because it was visceral for me. Remember what's his name, the reporter with the big mustache, reporting from Geraldo Rivera from the Silverdome in New Orleans, and he says it's rape and murder and all these things are going on, and I'm looking at this, and I'm like, this is America. This is a major city in America, and I distinctly remember the Louisiana National Guard were in combat in Iraq, and we flew C-17s all the way to Iraq, pulled them out of combat, loaded them into jets, and flew them back to New Orleans. And when they hit the ground, they were interviewed, and they said, which looks like we never left Iraq. Just think about that. So major city, just within a few days, goes from the height of civilization to basically worse than the worst times in the wild west. And so the first responders fled. The firemen, the cops, they all abandoned their posts. And so when you start to think about society, this thing that brings us together, this digital infrastructure, it's not just about, hey, making sure I can do credit card transactions on a bad day at Costco. It can be about the difference between life and death. And so that's the part that we focused on as a company. And as you start to get into it, one of the things that makes a lot of business sense that doesn't really make a lot of sense in terms of preserving life and liberty is this idea of centralization and consolidation. So we have highly, highly centralized infrastructure today. And it exists both in terms of how we look at the cloud, and it exists in terms of how we look at the networks themselves, right? So back in 2020, Christmas of 2020, there was an attack on a switching center in Nashville, Tennessee. That it was a AT&T contractor that had worked at AT&T, understood the layout in the region, basically filled up his motorhome with explosives, parked it in front of the switching center, and let the thing off. Now, Tennessee's a fairly good-sized state, but there was a single location that this guy knew that if he hit, he would take down service in Tennessee and surrounding states, and he did for several weeks. Now, when I talk to carriers, I'm not gonna name names, but one told me that they think they have a resilient network, and their explanation to me was, well, we have 400 cows. I don't know if you would, not the cows with spots and give you milk, but cows, sell on wheels, right? So we can move capability into the local area rapidly. Well, that's not always true. Typically, when you have a natural disaster, you have flooding. And so in a lot of ways, a lot of times, you're not able to get that infrastructure in place. So when somebody talks to me about resiliency and said, well, we're gonna put infrastructure in place in real time, that's not resiliency. When you kind of think back to the Cold War, I know it seems a long time ago, but we're actually back in it if you haven't been paying attention to geopolitics. When you think of the Cold War, we spent a lot of time figuring out how to have warning systems that actually kept the population informed about natural disaster and attack. We were much more resilient back then. We were a lot less reliant on digital communications as a means of getting things done. You look at the kids today. I mean, they really don't have a lot of coping skills when you take the device away. They don't, because the device is kind of their lifeline. Think about that. And so, we had things like giant voice, these large speakers that would, broadcast. We still have those on military bases, by the way. The government has spent a lot of money, our government has spent a lot of money on hardening AM radio stations. I bet you didn't know that we have AM radio stations that are out to broadcast, messages from the government. We were just talking to one of the stations the other day. Well, turns out they don't know how to communicate amongst each other, right? And here they're supposed to be the ones putting out the signal. By the way, who in here has an AM radio? Yeah. It's bingo. And, so you're like, okay, so we have this great infrastructure designed to notify people. By the way, what happened 6 months ago? The United States sent out text messages across the United States to say, hey, we have the ability to message you. And in fact, almost a year ago now, New York City put out a public service announcement saying, hey, if there's a nuclear attack in New York, go to your home and we will notify you what to do next. And people are like, how the hell are you going to notify us? And so as you take a step back, you're like, we are living on the precipice of disaster just because we have not put forethought into in how we keep civilization going in the event of the worst case. And the worst case is not that far-fetched. It doesn't take a hurricane. It could take a high-altitude nuclear weapon. We can take a well-placed solar flare, just like we've been experiencing here recently. And we are not ready for it. And so as you start to get into the infrastructure itself, we've been working with the carriers, and we started to look at the towers, the macro towers. And the macro towers are really interesting constructions. They pull about 50,000 watts of power off the grid. and they pump a lot of RF energy out in the space. And you start to get into why are we putting so much power into a single location that supports cellular communications? And it turns out that it is so hard to get a cell tower built because of all the permitting and regulations. It's not that you can put the thing up pretty quickly. That's not the problem. Communities complain, constituents sue. By the time you're done, you've spent 2 years and roughly $2 million to put up a macro cell tower today. So you want to pump as much power out of that cell tower as you can. And so we're all environmentally conscious, right? We want to protect the environment. And you start to think about this. We've actually created a situation because of how difficult it is to build cellular infrastructure where we have to be highly centralized, right? Economically, it makes sense to be highly centralized. And so we started looking at how do we harden these macro towers? Well, it turns out you can't affordably harden a macro tower because of all the power you're pumping out of it. There's also a physics problem here. For every 10 times you increase the power to the radio, you're only getting 3 times increase in range. So you're actually getting diminishing returns from the get-go. And the more you increase the power, the worse it gets. And what's happened there from physics perspective? Instead of pushing out RF, you're pushing out heat, right? So we are literally in our infrastructure pumping heat into the environment because of the way that we build things. Now, when you start to put those two things together, hey, we need resilient infrastructure, and the way we build it is highly centralized. Economies of scale don't really work. How do you really start to focus on that problem? So we looked at it, and it took about a year, but we started looking at it and say, hey, how do we take resiliency and inject it into the macro tower structure? And it turns out you can do it quite affordably. And the answer is really just providing a little edge compute that's closely located to the cell tower. You don't want it on the cell tower, though, because if that's the thing that's it, then it kind of defeats the purpose. So, what we came up with was this idea of basically dispersing edge compute and then connecting it into the cell tower to provide that local resiliency. So when you start to think about, okay, how do we do that reliably and deal with all these issues, you still have some things that you cannot defend against. You can't defend against an EMP. You can't defend against a solar flare because you can't reliably and cost effectively do that at the macro tower. So if that happens, macro tower is gone. But there are other resiliency challenges that you have. Like, in fact, we were doing a demo at Whiteman Air Force Base last November, and in the middle of the demo, I kid you not, somebody dug up the fiber to the cellular infrastructure in the local area. And all the carriers were on the same fiber provider. It was actually one of the carriers' fiber, but they dug it up, and so all the towers go out. And so we start getting hammered with all these devices trying to connect to our network, and we're like, what's going on? I look at my phone. I was a well, I won't say who I was a subscriber of, but I had 0 bars on that network, and I'm like, okay, so the network went down. So here's a perfect example why this is so important. And so somebody could dig up the fiber. Somebody could cut the fiber. Somebody could take out the data center where the core is located. Now, carriers would like to tell you, well, we have multiple data centers and the cores are working. Well, that actually turns out to be a really good problem in my former life, right? We just look at the topology of the infrastructure of the country and say, okay, honestly, for B2, taking out all the carriers in the United States is not a hard problem. One airplane, take out all the carriers in the United States. So you think about it from availability, it's not hard to attack this infrastructure because it's highly centralized. So starting to think about that. So we can't protect against EMP, but we can protect against somebody digging up the fiber, right? But we run into another problem with the carriers, and what is that? That is that they don't want to share their infrastructure, and so that becomes a problem, right? Because in order for us to protect that infrastructure, you have to open it up and share it, right? You have to use something called MOCN, multi-operator core network. And that has been used in Europe. It has been used in Asia. It's never been used in North America. And so thinking of different, you have to begin to think differently about the network if you're going to harden it, if you're going to resilient it, if you're going to make it effective for critical communications. That's really what we're talking about. The things that you want to preserve, as we've talked to retailers, I mean, a lot of the big thing that they're concerned about is be able to run credit card transactions. So financial is a big one. First responders, being able to get first responders, being able to get medical help. These are all key capabilities that resiliency and availability are a key component of. And right now, I can tell you that we don't have that. We don't have that. You give me a country, and I will tell you they're not ready for the attacks that are coming. So, Carl brought up things that have gone on in the recent past, but we are getting to the point where the infrastructure is a key component of attack as part of our current geopolitical state. And it makes a lot of sense, right? The United States cannot respond to any type of outside the United States crisis if they're dealing with a crisis of their own domestically. And that's the idea here, is using critical infrastructure as a means of creating an inward focus on society. Now, that's what we do in the military, or did. That is what's happening. And there's so many ways that you can do it. So it's not just the physical, in terms of EMP. There are so many other things that you can do. And if you saw with Volt Typhoon, we have stuff lying in wait, ready to go after our infrastructure. And so we really believe that unless we're all going to go back to using AM radios, which I don't see anytime soon, that we need to do something about this. It's not just a business problem. This is a societal problem. And when you start to get into the other reasons behind how you preserve and protect resilient infrastructure. So the physical tamper. Tamper is a very big part of it, because Volt Typhoon was attacking older routing equipment, for example. But there's also a way, once you physically have access to infrastructure to do things, and I don't know if you are aware of how physically we protect. And now you guys protect data centers. I mean, there's all kinds of security precautions, but at most cell towers, it's a 4-button code to go into the baseband unit room, and you have total access to all the equipment, right? Because the carriers need to get in there, and usually there's 3 carriers in the U.S. There's 3 carriers on a single tower. So one carrier needs to come in and start to have access, and they have access to all of them, right? So physical access to infrastructure is a big problem. So tamper is a challenge, and typically it's only something that the military does. And then when I talk to my peers in like the defense primes, and they're like, yeah, we have tamper programs, but they're all classified. So that has not made it out in the commercial sector, right? So EMP hardening, tamper. The other thing, when you start to think about co-locating with a cell tower, is that cellular equipment operates at -40 to +50 C, right? Because it's out in the open. It's got to operate at extreme temperatures. And you don't have a constantly cooled environment for your cell infrastructure. So that means your data center has to operate at -40 to +50 C. We don't typically operate data centers at Nobody would want to live inside a data center and like be the one checking IDs when you're coming in if you're having to be exposed to elements. So we don't do that either. So all of these things, EMP, tamper, cooling, thinking differently about the infrastructure is something that is really required and something that unfortunately we don't do. When you start to get into beyond just a physical layer, thinking, DoD has this zero trust framework for looking at infrastructure, and I highly commend the concept of zero trust infrastructure. Unfortunately, I don't think we take it far enough. In fact, the best zero trust strategy I have ever seen actually exists in the way that we operate and use and maintain nuclear weapons. That is the ultimate of zero trust. And it's something that we call nuclear surety. And most people aren't aware of nuclear surety, but there's three components. One is the personnel. So how many companies have a program that says, okay, not only are we going to monitor, or we're going to vet the people that we hire, but we're going to monitor them not on a daily basis. We're going to monitor them on an hourly basis. Are they having marital problems? Are they having financial problems? Are they having drug addiction or other mental health problems? Right? Who's reporting on that? So in nuclear surety, we have something called the Personnel Reliability Program. And the idea here is that you report on yourself and you report on, it kind of sounds a little bit like Iraq. The Saddam Iraq, like everybody's reporting on each other, but it's not intended to be punitive, right? So you can have a problem, you can say, hey, I have a problem. I have whatever my problem is. I have a gambling problem. It's not intended to be punitive under the Personnel Reliability Program, but it's intended to get you help. So, but while you're getting that help, you're pulled off status, right? They don't want you touching nuclear weapons. So if you start to think about nuclear weapons and the stuff that goes in them, highly enriched uranium, highly enriched plutonium, you say, hey, that's the secret stuff, right? We like to say data is oil, but in reality, data is like highly enriched uranium or plutonium. That's the secret stuff. And maybe today we don't want you touching our data or other people's data. Maybe just take a day off and we'll get you back. So the personnel piece is actually a very important piece. Equally a part of it, every time, whatever we do within nuclear weapons, there are two people to do it. And there are two people that are knowledgeable about the task, and they are there to not only do the task, but observe each other doing the task. So thinking about what are those critical functions. So, we just had AT&T had a big service outage in the United States, supposedly due to a software update. So we won't actually comment about that, but think about it. What are those things that are critical, like you were talking about, where you have an outage and it basically becomes an availability problem, and how do you what are the procedures and processes by which you implement those things, right? Is there two-person control? This is something that as you get into the personnel, okay, now we have the personnel, we've vetted them, we're monitoring them, and they're monitoring themselves. It's non-punitive, but it's just to ensure that they're always operating at peak performance. But to guard against that, we have policies and procedures. So personnel, procedures that say, okay, every task that we do that could inject an availability problem into the system, we have to do it together, right? So, for example, dual person authorization, not just dual factor authorization, but dual person. Somebody says, hey, we want to do this, and then it requires a completely separate person to come in and say, yes, we want to do that. So procedures are a real important problem in implementing those in those areas where that if I get this wrong, or somebody else deliberately gets it wrong, then somebody else is there to say, okay, hold on a second, is that really what we want to do? And finally, the technology. So the material, how it's designed. One of the things that we looked at in terms of how we run infrastructure today is that the control plane and the data plane are coincident. And that can be a problem if somebody gets into your control plane. And so we believe, really the most secure way to think about the system is to physically separate those two, right? I don't want my control plane running over the same pathways that my data plane runs over. I want to keep that completely separate. It turns out that space provides a really good platform for your control plane. Why? Because the control plane is not latency sensitive, right? Data plane is latency sensitive. Control plane is not. And the other thing is that the control plane doesn't require a lot of bandwidth. Control plane is a very narrow band. So narrow band, not latency sensitive. What does that sound like? It sounds like I can put that up in space. And what does that mean when I put it in space? Well, it means that I can control through just a few pieces of infrastructure this control plane from end to end on all my locations. So, there's a lot of things to think about when you take a step back and you look at the world today. You look at how we have built it today, and we look at how vulnerable we are because of the way we built it. And it turns out there are some cost-effective ways that you can think about making that infrastructure resilient. Now, it requires, I think, a community view of this. The way we think about infrastructure, in particular making infrastructure more resilient, is it needs to be a shared resource, right? When I was at the White House, looking at infrastructure as a problem, as a vulnerability for our society, and I started to look at how we build networks, the carriers were not happy about that. I don't know if you may remember there's a great article that came out of Axios called Trump Administration Nationalizing 5G. Now that article, actually, you can go to it now, you can look it up. That article was a hit piece because of the report I was doing at the White House on how do we make our infrastructure more resilient and secure. So the telecom industry found out I was working on it, got Jonathan Swan, who was the guy that got all the leaks in the White House, to write this fantastic hit piece. And I still remember, I was out hunting with some friends, and I got a call from the White House. I said, "Do you know anything about this paper? Getting to this." Turns out, no joke, the White House itself leaked the paper. People within the White House leaked the paper as part of a hit job. I was a pretty naive one-star at the time. But do you know anything about this paper? I'm like, no, I never sent it to the media, and actually never sent it outside of government channels, so that's why I knew who had leaked it, and because there's only a few people that had it. And so I talked to the reporter, and he goes, "Yeah, so tell me about this. You're nationalizing 5G." And I said, "The paper's not about that. The paper's about what are the opportunities and challenges with 5G. The opportunity is to make our networks more resilient. And why is that? Why is 5G just a thing? Well, the thing was you could basically, it's all in software, except for the digital, the analog to digital analog conversion that happens at the radio head. Everything else is software that runs on COTS servers. So what do you know about software? There is no logical reason to take chunks of software and split them up when they can all run on a single server. No logical reason from a resiliency standpoint, because as soon as you lose that link, you lose that piece of infrastructure. That was a feature. That's how we built networks in the old days, right? We don't have to do that when you have a software-only network. You can run it anywhere. And you can run all of it. And so if you lose backhaul, you don't need to lose your network. And so I said, finally we're at a place in cellular networks where we can actually make them pretty resilient, and we can make it resilient by consolidating the software. And who needs that resiliency and security, actually the most today? It's the military. And the military has this problem that I've lived through for my entire 30-year career, and that is interoperability. I have 15 radios and none of them talk to each other. I still remember being stuck at a desk on the flight line. I've got a UHF radio here that's mounted to the wall, and I've got a land mobile radio, push to talk, walkie-talkie, that I can walk around with. And I'm like, so I call up the comm squadron and I say, hey, can I put these two together? And this will just kind of give you, it's a small story in the history of my life that just tells me a lot about why and how we do things. So I'm like, hey, can we stick these two things together? I need to go do stuff, and if I could just talk to this UHF radio that's bolted to the wall, then I could go do my stuff. And they're like, yes, we can do that. And I'm like, great, let's do it. And they said, well, it's illegal. So remember the tower problem? It's 2 years, permitting, suing, everything. So I'm like, who says it's illegal? And they said, well, the frequency manager at Air Combat Command says it's illegal. I'm like, okay, who is that person? So I call them up. I said, hey, I want to take this radio and this radio and stick them together, and I'm going to go walk around. And they're like, okay, that's fine. So I call the comm squadron, and I'm like, okay, the frequency manager told me it's not illegal. And they're saying, no, it's definitely illegal. So I call back the frequency manager. I said, hey, can you send me something in writing that says this is not illegal? So I can take it and send it to the comm squadron. And they go, okay, great. If you give me $40,000, we'll buy the equipment and we'll stick it up and you'll be able to do that. By the way, this is a year, so it really sticks to the macro tower thing, because it's a 1.5 year process this is going on. This is not that doesn't happen in a day. So I go get the equipment and I take it to the comm squadron and said, hey, I've got to deploy to Guam for a couple of months. I'm going to come back and I want this to be operating. And come back, there's a sticky on my desk. And they say, please call the comm squadron. Call the comm squadron and say, hey, so I think they're going to say, hey, come and bring your radio to program it. They're like, hey, if you bring us that equipment, we'll set it up so that you can use the radio. I'm like, I brought it to you 2 months ago. So anyway, I went to security forces and I said, I need to report somebody stole my radios. Needless to say, we got it connected the next day, and I took it in the ops group commander's office and said, here you go, you can call the jets. Well, you can literally, from that thing, call the jet. And so, when you think about that, in terms of what we have, it's a funny story, but first responders have this problem all the time. I talked to a sheriff in Rockwall County, Texas, and he goes, we are all on the same P25 system, but the Texas DPS helicopters, when they fly over, they're on a different system. We can't talk to them. It turns out that when you consolidate this infrastructure near a tower, you can start to blend in all these legacy communications that don't talk to each other, and you can bring them into if you can bring them into IP traffic, which you can do pretty easily, you can start to bridge them. And so it's not just you're able to make your infrastructure more resilient. You can start to, as you get decentralized, right? That's the key. If you haven't figured it out, the key theme to the story. If you can decentralize, you can do it at scale, you can do it cost effectively, and then you start to solve a whole bunch of problems that we cannot currently solve because we are so highly centralized. So I think with that, I'll stop and open it up to any questions.
So just going back to your earlier about the resiliency behind the towers, more and more providers are using smaller cells using millimeter wave. Does that make the issue harder to handle, or does it help in any way? And especially when it comes to the latter point of consolidation, right? Because if you're distributed in the microcells, and how do you consolidate these services when now they're kind of spread out into little pockets?
Right. So that's a really good question, and that thanks for asking that. So as you start to get into this radio problem, where every time you pump the power into the radio, you're pumping out more heat. It turns out that it's a very inefficient way to do infrastructure. Again, when we're talking about cost effectiveness, we're burning energy to heat the atmosphere rather than allowing us to connect. And so being smaller actually allows you to bring the power down. When you bring the power down, you can actually build small cells that are completely off-grid, right? They can be so low power they're off-grid and yet still provide good coverage area. We're talking about miles, not feet, like Wi-Fi. And if they can be off-grid, they can be roof-mounted. If they can be roof-mounted, then floods aren't going to get them. So now you can do cost-effective, off-grid, highly decentralized, but yet still provide the same kind of connectivity. The only thing that I would say is on those small cells, millimeter wave's not going to cut it because the range is just not there, and it doesn't penetrate walls, doesn't penetrate your skin. It's just water, anything. So it still needs to be in the sub 6 gigahertz range in terms of getting that range out there. But in terms of how you deploy infrastructure cost effectively and resiliently, it actually turns out to be small cells are a much better way to go. Again, the reason we've built the towers the way we've built them is because they've traditionally been these honking giant radios that they wanted to put up in these giant towers and blast out everywhere. But there's no reason to do that anymore. And I think technology is 5G has given us really the means of thinking differently about the network. I mean, infrastructure is really no different than this when you kind of take it down to its elemental level in what we're talking about. It's got a computer, it's got a networking equipment, and it's all you can be all self-contained. And so that's what we're talking about. So yes, rather than having a radio that takes 10,000 watts to run, 5,000 watts, a couple hundred watts, you can still provide coverage for a community. And in that space, you can also run critical applications. So if there are things that you need to run that are absolutely essential, those applications are best run locally. So how do you connect all that together? Well, it turns out that you can use the as long as you've got an ability to create a gateway. Even if you have things that come up on a satellite network, every one of them are going to have a different IP address. But as long as you have a gateway where they all connect into, again, control plane in space, now you have the ability to as soon as that node comes up on the gateway, boom, it's connected, and you make a call to any other gateway. So it is a different way of thinking about it, right? Because in cellular we have a centralized core running, where we connect everything. No, this is highly decentralized, where the thing that is synchronized is just a subscriber database, right? And that subscriber database says, hey, Joe is on this node, 1,000 miles away, and that's where you need to go if you want to talk to Joe. Again, a different way, highly decentralized, different way of thinking about your architecture, but just as effective, just as easy to implement today. I can do this. I can pop 2 cells up, in 6,000 miles away, and we can make a call like that within a few minutes just by having an architecture that allows for that.
What do you think about the technologies like the helium networks, so completely decentralized, crowdsourced networks? They're running on 900 megahertz today, which has a lot of low speed, but the problems with water and trees and concrete are minimized. And this is version 1. Are you familiar with helium?
I'm familiar with helium. So it's not decentralized, right? Because if you lose connection to the central, your cell goes out, right? It's not a decentralized network in that sense. There's not a decentralized core. Still a centralized core. It is a decentralized network from, in terms of crowdsourcing the small cell itself. So in that sense, the model is an intriguing model, from in terms of, because so there's the part that I agree with regard to helium is that it gives the individual agency in terms of contributing to a problem that we all collectively have, right? And it gives you, it rewards you for doing that, right? It rewards you for building the infrastructure. It's just, I would like to see that be a truly decentralized cell that is not reliant on anything outside of that local area, because you got to plug it in the internet in order for it to work. What we're talking about is something you do not have to plug into the internet to work. It sits right there, and it becomes a truly decentralized piece of infrastructure that may be intermittently connected or not connected at all, but it's still going to function to provide some capacity. But the idea in terms of crowdsourcing infrastructure is exactly, I think, the right idea. All right. Thank you.